Okay, here, this is question number 12, at least it is right now in the Laplace transform homework. We're going to do this Laplace transform of a piecewise function. And we can't use a Laplace table here. Like, I don't know, maybe there are Laplace tables out there that have a generalized version of this, but that would be so much more work than just doing the integral. That's the way we do this. We just do the integral. By definition, the Laplace transform, capital F of S, is the integral from 0 to infinity, f of t, e to the negative st dt. We're integrating with respect to t here. That is the key. All of my t's will disappear. All of my limits are t limits. My answer is going to be a function of s. Okay, so we're going to split up my integral. I'm going to go 0 to 1 using this as f, and then 1 to infinity using 0. Well, that part just goes to 0. I mean, it's just integral of 0. That's 0. It's a definite integral. Technically an improper definite integral, but it's still 0. So now we got to do this guy. And I'm going to split this up. I'm going to distribute here. And I'm integrating from 0 to 1. And remember, these limits are t's. T equals 0 to 1. This guy here, I have to do integration by parts on. That one's easy. That one we'll just do in a second. So here, integration by parts. Anytime you got a polynomial times e, you always want the polynomial to be your u, because he gets simpler as you take derivatives. So u equals t, du is dt. This guy then must be dv. Integrating that, you get v. Then that antiderivative will be antiderivative u dv is uv minus integral v du. You guys know this. So we're going to uv, u times v, evaluated from 0 to 1, minus the integral of v du. There are so many negatives here. We got to be careful. That minus is from the integration by parts formula. That minus came right here when we did this antiderivative. We picked up a negative 1 over s. Those negatives are going to cancel out. But now when I do this integral, this guy's antiderivative, we get a third negative 1 over s squared there. And this is all evaluated from 0 to 1. So you can check all my arithmetic here, plugging in t equals 1 and then t equals 0. You get this. Then we still had this guy here, but he's easy. You just get negative 1 over s e to the negative st, again from t equals 0 to 1. And that 9 comes along for the ride. Now we want to add like terms together. So that guy there and that guy there are like terms. We get negative 10 of those. Nothing else is a like term here. So this guy, and that guy. Can be a little challenging. A lot of places, especially with the negative, you can mess up.